Welcome. Today, continue angle section, last class, closing class. See, first of all, angle section or L section people call. See, angle can be like this, or angle can be like this, or it can be like this, or it can be like this. Actually, once you solve one of them, all are same. But still, I want everybody to understand each and everything. So, I am covering all the types. I think first question this way, this already over with this now. I think this is pending, I think. I will check that one. So, next question I will see that which is pending, I will do it. Okay, start. Find moment of inertia and also radius of gyration about centroidal axis. Centroidal axis, not axis, remember. Okay. All dimensions are in millimeter, I told. 150, 115. I am keeping same thickness because thickness can be different. We have solved the question earlier. Later I will give exercise question. When I come to exercises, I will give different thicknesses. But why I am giving same section? Because this 150 longer side, 115 shorter side, both equal thickness, it is there in the steel tables. So, it is there in the steel tables or IS handbook. And there, I told, some curvature is there. So, light changes will be there because they account for it. But we are solving in engineering mechanics now, concerning rectangles. So, I will give property later. That is for those who are interested in steel structures. Okay, start this question. Class, I won't waste time now. See, these all you have now onwards, these all is your responsibility. Moment of inertia about centroid and also radius of gyration about centroidal axis required. I told you centroidal axis means axis passing to centroid of the entire cross section. I told capital G, red color, one horizontal, one vertical. Even inclined are there? No. If it is not mentioned, understood, which one? XX and YY passing to centroid. So, they want IXX, IYY, RXX, RYY. You write here. These are all required. Not this way. Those who are serious should write everything. Start. First, prepare. See, we will divide like this. See, this way divide. Your choice. 150 by 12. Then here, this is 100, total is 115. 12 already over. From 115, subtract 12. This rectangle depth is 103 and 12. Okay. Then, if you want by chance, from here to here, how much? See, this is 150, subtract 12, you get 138 for information purpose. Okay. Now, first write. Again I told you, you should write. First is what? If you want I about XX and I about YY, you should locate XX and YY. So, for that, you require to locate centroid. To locate centroid G. Centroid G for the entire cross section. Now, statements you have to write. I will not. This is over thousands of times earlier. Consider reference axis, see, passing through O here, left bottom left corner, some Abel-Co, Eter-Co I told earlier, leave it now, see, O, reference axis, OX this way, OY this way, through this point. Then, from x-axis, from OY axis, see, I told you, from OY you find x bar. From OX you find y bar. Write formula, x bar equal to, write the formula, x bar from OY equal to A1, sorry, I am not telling formula now. And also write formula for y bar from OX. These all you have to write. If you are serious, you will write. If you are not serious, what I can do? Okay, then after all the steps I told already regarding centroid location, first of all, I should not talk about this one. Come here, mark centroid and tell this is for you. Still I am writing. See, start. Therefore, x bar, see, x bar from reference OY axis. This color problem is there for me. From OY. How? x bar you are taking to right side. Okay, equal to, start calculating. I am doing only calculation part. I will take 1 and 2. A1, 150 into 12. If somebody is not clear, 150 into 12 is A1. 12 into centroid here, from here, x1, 150 by 2. Space problem here, I am writing one below other one plus second one. You write horizontally. Here space problem, see it will go out of the camera. You write horizontally. See, actually you should write somewhere here. Okay, okay, I'll write here. Okay, I got space here. Okay, I write. Okay, don't see this side. Okay, start. X bar, don't see these things. From OY to which side? To right side. Equal to, formula you write A1. 150 into 12 is A1 into its centroid from here is 150 by 2 into 150 by 2 plus second area 103 by 12 or 12 by 103, your choice, by 12 into, from here to centroid is G2 is 12 by 2, 12 by 2 divided by, you can do one thing, make a small note. For x bar you require area, total area. For y bar you require total area. For radius of gyration, again you require total area. Therefore, instead of wasting time everywhere, you write somewhere here to locate centroid G, total area A equal to A1 plus A2 equal to, how much A1? 150 by 12 plus 103 by 12. If you write that way, useful for you. 3036. See, in the corner there, I noted all the answers, mm square. So therefore, divide by A1 plus A2 is 3036. You will get the x bar. X bar will come 46.909 millimeter. I already calculated. 46.909 millimeter. Okay, then, and y bar from OX axis. From OX, how y bar? Y bar we are considering upper side equal to, start calculate OX equal to. From here you are doing y bar, upper side. First area, 150 by 12. 150 by 12 is A1 into its centroid from here is, see, from here to here is 103 plus 12 by 2. 103 plus 12 by 2. Either you write 103 plus 12 by 2 or 115 minus 12 by 2. Actually, again I am going to centroid, wasting time. Plus 12 into 103 is next area. Some sound is coming there. I want to finish part this recording now, this part. Into 103 by 2. I don't know why such odd time, night, midnight all, they are playing music there. Divide by total area. How much? 3036. You will get the y bar. It will come, it is answer 85.591. 85.591 millimeter. Okay. Now some statement you are right. Go back to this sketch and correctly, oh, this should be slightly this side. Okay, okay. Not. Now go back here and locate it. See, from here, x bar we got 46.909. This is how much? 150 means 75 midpoint. So it is somewhere here. See, this is your YY axis. See, sufficient YY. From here to this YY axis is without disturbing 138. See, when you come here, red color marking, this is 46.909. That is your x bar. Okay. Immediately calculate from this side. From total 150, subtract it. 103.391. This all I made ready earlier before the class to save the time. And from here, y bar we got 85.591. This is 103. See, somewhere here. How much you got from here? This is your y bar. 85.591. Then immediately from top edge you write here. From total 115, subtract it, you will get 29.409. 29.409. Okay. Now the intersection point is centroid for the entire cross section. About that we want moment of inertia now. Okay, start. Now, this I will remove now. These are all over. This not required. Area I require 3036. Okay. 3036 area. Okay, I already told for you. Why should I write once again? X bar, Y bar now not required. Now, start. Calculation of moment of inertia I by statement, by parallax theorem. This I have been telling from class after class. Each term you explain and write. Start now. See, I about x-axis. This is x-axis. Start here. First, I about, see, it is for figure number 1. Its own centroidal axis. Axis passing to centroid of the component parallel to x-axis. Parallel side is 150. So it is 150 into 12 cube divided by 12. This is your IG plus area. 150 into 12 is the area into from centroid to of that component to x-axis axis. See, this distance square. That distance is 29.409 minus half of 12 minus 12 by 2 whole square. This will give I about x for your part 1. Next, plus I about x of part 2. First about its own centroidal axis. 12 into 103 cube by 12. If someone will ask, sir, wise means no answer from me. Plus area. 12 into 103 is the area into from centroid of the component to x-axis axis, this distance square. That distance is how much? See, this is 85.591. This is 103. From here to here is half of 103. We want, see, this distance square. That is 85.591 minus 103 by 2. Minus 103 by 2 whole square. That's all. IG plus AH square. Calculate. Your IXX will come. Everything is over now. Calculate IXX. Total answer equal to, total answer. I write here answer. Okay. Equal to, I already noted there, IXX. 3.537 third decimal sufficient into 10 to the power 6 millimeter power 4 is, therefore this is your IXX for the entire. Okay, now start. I about YY axis. Come here. First I about its own centroidal axis parallel to YY. So 12 into 150 cube by 12. Y means, don't ask me. This nobody should ask now. Why this way? Then what you are doing all these days? Okay. IG plus area 12 into 150 is the area into from centroid to YY. This distance square is 103.391. See, so crystal clear. 391. We want this distance square. From 103.391, subtract midpoint distance 150 by 2 minus 150 by 2. This is to be squared, fully squared. Okay, over. Black color bracket. That is for first figure. Second one, where is it? Here. First I about its own axis. this axis. Parallel side is 103. 103 into 12 cube divided by 12 is Ig plus 103 into 12 is the area, Ig plus area into from centroid to this axis. See, I about Yy. This distance square is 46.909 minus 12 by 2. So crystal clear. 46.909 minus half of 12 whole square, close the bracket, total, therefore you will get the value of I about Yy. How much I got the answer? Iyy. 6.909, 10 to the power 6 millimeter power 4 over Iyy over. Now last part, okay. Calculation of radius of gyration. I need not write gyration, that is R, about centroidal axis. About centroidal axis. Centroidal axis. That is, we have to find R about XX and R about YY. Now, it is your problem. I won't waste time now. You write, in general, radius of gyration R equal to root of I by A, or R about any axis equal to square root of I about that axis divided by area. Therefore, R about XX equal to square root of I about XX divided by total area, and R about YY axis equal to square root of I about YY divided by total area. Now, substitution part, you do it. IXX is here. Area I told is how much? 3036. Substitute, get the RXX. Where is it RXX? 34.132 millimeter. See, when I solve so many questions and repeatedly comes, making fair copy, writing systematically is your duty, not my duty. My duty is to make things clear. Same way, RYY. IYY is here, see. Here. Area is already there, you know area. Substitute, show the calculation, RYY will come 47.704 millimeter. Okay, this will complete the question. Okay, now, information for those who are interested in steel structures. See, 1 minute here, I write here. This is the angle given. Where shall I write? RXX, I want to, 1 minute now. I write here, how much RXX you got? You got RXX equal to 34.132 millimeter. RYY equal to 47.704 millimeter. Okay, done. Because I want some space now. Millimeters, okay. Now, make a note. Longer side 150, I am dictating something for those who are interested in steel structures. So in future also it will come there. Those who are not interested can stop. You need not continue. Suppose you are not interested in steel structures, what I am telling now, don't worry about it, leave it. But remember, after that more questions are there. Not that close the class here. You go further and search when I am doing next one. Okay. Now, see, this is an angle of long, one side 150, one side 115, thickness 12. This is called unequal angle in steel structures. Unequal angle. This angle is there, right here. This particular angle is there under the name ISA, Indian Standard Angle, 150 by 115 by 12. That means you place whatever way you want. Longer leg of 150, shorter leg of 115, both thickness 12. And in IS handbook, they printed properties like this way. See, when they don't know how you print property, how you use it in the construction. So that is your problem. They printed like this. When they give property, they are shown longer leg, don't see there, vertical. And then, so this is 150, this is 115, 12, 12. Then they told, see, centroid is somewhere here. Centroid, G, for the angle. They told this is the horizontal axis or parallel to shorter. This is x-x axis, they told. This axis, they told y-y, there, y-y. And this distance is, we call x bar, but no, they called it as centroidal distance of y-y axis. See, centroidal distance for y-y axis. This distance they called, this is x-x axis, centroidal distance for x-x axis. Then in the property they told area equal to, I noted down, 3038 mm square. Then they told Cxx equal to 46.4. I all copied from IS handbook. They told Cyy equal to 29 millimeter. Then they told I about xx equal to 6.765 10 to the power 6. Actually 10 to the power 4, they given millimeter power 4. They told 676.5 centimeter power 4. I converted to millimeter. And then they told Iyy there, not told, printed there, Iyy 3.453 10 to the power 6 millimeter power 4. And then they told R about xx axis is 47.2 millimeter and R about yy printed as 33.7. Actually, it is printed as 3.37 centimeter. I converted it to millimeter. Okay, now do one thing. But here, see, when they give this property, they consider, see, some slight curvature and also, see, curvature here. Little area here made flat and here little more area. They accounted for it. Even they know what is the radius for this curved part. Radius at root it is called. That all is very in steel structures. Therefore, what values are given in the IS handbook will not exactly match with this one. See, in the engineering mechanics class, what all we got, we consider straight edges, rectangles. So, but there is curvature is there. So, slight fluctuation is there. That is okay. See the answer now. See, they told area 3038. In our class we got, for this one, we got area 30, how much it is? 36. Oh, area is almost matching. Okay, then they told there this Cxx is how much? 46.4. See, that is not this distance, be careful. Cxx, they told 46.4 means centroidal distance. See, this xx axis, they measured from shorter leg. See, measured from shorter leg Cxx. So, if it is this way, here it is this way. See, shorter leg is here. This is that Cxx. How much you got? 46.909. They printed 47.2. 46.99 is almost 47. So, 47. And then they told Cyy, that is measurement from the longer leg. See, Cyy 30, how much it is? 29 millimeter. That is from the longer leg, see, this way for CG. Oh, 29.409. They told 29.4 millimeter extra. Okay, then they told I about xx is 6.765. So don't worry, this xx is not that xx. This xx is centroidal axis parallel to shorter side. Oh, so this xx is this yy here. See, parallel to shorter side is the axis here. So whatever they told I about xx there, you should get it as Iyy here. 6.765, 6.909. See, point some difference. And whatever they tell, which one? I about yy there, that is parallel to longer side here. See, turn here, you turn it here, it is nothing but, see, that is nothing but x axis. So your whatever they given Iyy should be your Ixx in the class. Ixx in the class is 3.357, 3.453. And also this xx is this yy. This yy is this xx. So what they printed as rxx should be ryy for us. See, 47.2, 47.7. And whatever they printed ryy should be our rxx. 33.7 is almost 34, 34. So make all this note. This over. Now I will go for one last question, question 6, where moment of inertia is not asked about centroidal axis. So some other axis I will give you. I prepare the last question for angle. Later, exercises, I will give plenty of questions. Now, question 6. See the question correctly. Find moment of inertia about an axis passing through O and O dash. That is two separate questions. Passing through O and O dash means two questions are there. And O dash, pass O and O dash, and I forgot. And I forgot right here. Passing through O and O dash and perpendicular to plane of the area. Plane of the area. That means, see, this is the plane of the area. First they want I about an axis passing through O perpendicular to this plane, this axis. Then they want about this axis. Okay, start. Something I will dictate in the class. See, class. What you do is, see, you make note what all I tell now. 16 and, okay, scale is not required. See. Consider point O. Through O, you consider one axis OX. Arrow mark also not required, simply see, OX. Or capital X also, small x will do, OX. Another axis here, OY. Then, perpendicular to the plane, I cannot show here, see, it is something like this, Z. Actually, this way, right? By we need, see, we need I about OZ. I about OZ, this way. Then write, by perpendicular axis theorem, I about OZ equal to, see, OZ equal to sum of moment of inertia about two mutually perpendicular axes lying in the plane passing through O equal to IOX plus IOY. So, therefore, if you want I about OZ, find IOX, find IOY and add those two, you get the answer. Okay, then make one more note. Okay, now this is over. Then one more note. They also want, see, point O is here, O dash, they called O dash. They also want IO perpendicular, OZ dash. See, you call O dash, so Z dash, O dash Z dash. See, O dash Z dash. They also want moment of inertia about an axis passing through O dash perpendicular to the plane. For that, see, you consider one axis X here, one axis Y here. But call, so understand, call X dash and Y dash and mark that Z dash perpendicular. Then write I about O dash Z dash equal to I about O dash x dash plus I about O dash y dash. Therefore, the question finally is what? Finally is, I'll write here now, finding I about Ox, I about Oy, I about O dash x dash and I about O dash y dash is the question. Okay, now start. This I already told you, whenever they want moment of inertia about any axis passing through a point in the plane and oh, this is required. Okay. I rubbed extra. I maintained it for required now. Okay. I'll write once again. And perpendicular to the plane of the area is sum of moment of inertia of two mutually perpendicular axes passing to that point lying in the plane of the area. Okay, start now. Calculation of I about OZ. Correctly, see OZ dash shown. So what you do? See, light. O here, this I told X, this I told Y, this perpendicular plane I told OZ. Okay, start. I OZ. Get what? Get I about OX and I about OY. For that, first divide into parts. See here. Divide into parts. One rectangle here. Now I am not going, answer I am not giving now. See one rectangle here this way. Little space required for me. 1 minute. Okay. One rectangle here. Of thickness, how much? 16. Thickness is 16. I will mark later. This is 130. I will divide like this. So I will stop here. Next, I will take one more rectangle here. See, this way. Thickness is little more. Okay. Now, this thickness is 16. This depth is, see correctly here, from 130 subtract 20, 110. Oh, both are 110. So do one thing, change the question. 130 to this thickness of 20, you make 18. I do not want same number. Change the question, the thickness of 20, you change over to 18. So this is 18. Okay, mark here. This is 18. This is from 130 subtract 18, 112. I do not want same number, 112 and 18. Okay. And total is how much? 18. Total is 130. Horizontally, this is 16. This is how much? This is 110 by 18. And in case you want this distance, see, in case you want this offset here, from here to here how much? In case you want, this is from 110 subtract 16, 94, correct? 94, correct? 94. See, too much of addiction for calculator means same thing happens. Earlier, when I was in high school, all these numbers I used to tell very fast because by basic mathematics. Now too much addicted to calculator. Correct? 94 plus 6 is 100. Correct. Okay. Now this we will take part 1, green color. Now question is over. This I will take part 1. This I will take part 2. Okay. Part 2. Centroid G1 is here. G2 is here. Okay. Write this one. Now make a note. Moment of inertia is not required about centroidal axis. So this question, x bar calculation, y bar calculation and location of centroid G is not there. Directly start. Directly mark required axis, red color axis and start finding moment of inertia. So I will take the point as O here. See, this 2 is disturbing me too. Okay. It will disturb next time if I write there. Next to, where I write, okay, here. There also it will disturb, okay. This is 2, okay, no problem. Some disturbance here, this is 2, okay. Directly mark O and mark X here, small x, I will take OX. I will mark OY here, okay, start. Now, calculate I about OX and I about OY. See, I write here now, by parallel axis theorem. Parallel axis theorem is actually how many times I have to write I about any axis equal to Ig plus area into h square. If someone will ask, sir, not clear for me, leave my class, go to some other place where they teach better. Okay, start. Therefore, I about Ox equal to, start, I about Ox. First come to centroid. About axis passing to centroid parallel to Ox axis. See, this axis. 16 into 112 cube by 12. 112, correct? Yes, 112 cube divided by 12 is Ig plus area. 16 into 112 is the area into from centroid to OX. This distance square is 112 by 2 plus 18. Red color, okay. That is red color. Why? Distance square. 112 by 2 plus 18 whole square. Next. Plus, this is for figure number 1. Figure number 1 over. Plus, for figure number 2. I about, see, its own centroidal axis. Parallel to OX. 110 into 18 cube by 12 is area, Ig plus area. 110 into 18 is the area into from centroid to OX. This distance square is 18 by 2 square. Red color. 18 by 2 whole square. Calculate the answer. Get the answer in 10 to the power 6 millimeter power 4. Okay, then get the answer. 10 to the power 6 millimeter power 4, 10 to the power 6, your choice. Usually I take 10 to the power 6. Okay. Then I will put right answer. Then I about OY equal to, start. I about OY. First about its own centroidal axis. 112 into 16 cube by 12. 112 into 16 cube by 12 is Ig plus area. 112 into 16 is the area into distance of its centroid from OY axis is this distance square. Oh, that distance is, if you want, you can make full red color here. See, full red color here. Okay. That distance is directly 16 by 2 whole square. 16 by 2 whole square. Then plus I about OY you want. First I about its own centroidal axis here. 18 into 110 cube by 12. 110 cube divided by 12 plus 110 into 18 is the area into from centroid of that component to this axis. This distance square is 110 by 2 whole square. Get the answer. Say double right. 10 to the power 6. Write the answer in 10 to the power 6 millimeter power 4. Imagine double right. Therefore, write answer. I about OZ. See, OZ is here equal to, I already told you, I about OX plus I about OY. You know the answer here. Write those two. Write the answer in millimeter power 4 over. Answer I am not giving because why you want answer? When so much clarity is given for steps, Answer is no use. You write the answer. Over. Now, next. Calculation of I about O dash Z dash. Get I O dash X dash, I O dash Y dash. O dash Y dash. See now, see, red color is gone now, changing now. One more sketch you have to write. Don't use the same sketch. Once again write here. Now your O dash is here. See, O dash is here. So through O dash, draw one axis here, OX dash, and here, see, this axis, OY dash. And then this I'll remove. Get what? Get I about OX dash, and now get I about O dash X dash, and I about O dash Y dash. Start. I about O dash X dash, I about O dash Y dash equal. That's all. See, only this number will change, but you should not do that way. Okay, start. First, once again, beginning. Come to here. I about its own centroidal axis is 16 into 112 cube by 12 plus area into this distance square. See, this distance square is exactly 112 by 2 whole square. That plus is not there. See, last time it was 112 by 2 plus 18 is there. Now only 112 by 2 whole square. For this axis. First I about its own axis. 110 into 18 cube by 12 plus area into this distance square. That is directly 18 by 2 square over 18 by 2 whole square. Calculate. Imagine answer is right. Right dash is the answer. Right dash is the answer. Then I about O dash Y dash. Start here. I about its own centroidal axis here is 112 into 16 cube by 12 plus area into this distance square. Once again, it is how much? 16 by 2 whole square. Plus. Here be careful. When you want I about this axis, first I about this axis. See, it is 18 into 110 cube by 12 plus area into, now be careful, from here to here. See, this is 94. This full is 110. From here to here is 110 by 2. So 94, where is it? Into 94 minus 110 by 2 whole square is the answer. Let that answer be what? Double dash. Then write. Therefore, I about O dash Z dash equal to dash plus dash. Why? This answer plus this answer. Write whatever you get and close the question. Don't write dash. I wrote dash because who will calculate now? You see, when steps are in future also, when some moment of inertia is there, when huge numbers are there, if I show calculation, answer is not required. You can check among yourself only. Or don't calculate. You understand it. But whenever I give direct answer, without steps more or with brief steps, then answer is not required. Or if I give an exercise, problem, direct answer, then to check that you have done correctly, you require the answer. So when everything is given, answer is not required. Okay. I will conclude. Angles are over. Next class, I will go for T sections. Then I sections, I will continue. Okay. We will meet in the next class. Thank you.